our last section for this unit is the converse theorem. So we're proving that lines are parallel using the converse theorem. So maybe I'll put up a little something else going over each of those theorems. But the idea here is if we have alternate interior angles, 1 and 2, the alternate interior angle theorem says if the lines are parallel, then the alternate interior angles are congruent. Okay, but we've said that the converse for these theorems are also true. So if the alternate interior angles are congruent, then the lines are parallel. Same thing for alternate exterior and alternate and corresponding, right? If the lines are parallel, then the corresponding angles are congruent. So if this was, here's 1 and here's 2. I'm sorry, that's same side interior. 1 and 2. So if we had corresponding angles, it's saying if the lines are parallel, the corresponding angles are congruent. That's how we've been doing our proofs for parallel lines. Here we're going to say if the converse to the alternate interior angle theorem says if the corresponding angles are congruent, then the lines are parallel. So maybe I'll do another video, maybe I won't, I don't know. But let's just start. Okay. If you missed it from class, maybe I should make another video though. Don't know why I'm scrolling in here. So let's look at some example problems first, determine if those lines are parallel or not parallel. So right here we have alternate interior angles. Okay. The converse to the alternate interior angle theorem says if the alternate interior angles are congruent, then the lines are parallel. So our alternate interior angles have the same measure, therefore they're congruent angles, therefore the lines are parallel. So this is yes, P is parallel to Q. Okay. Here we have, we don't have an angle pair for this, so let's make one. We know these are corresponding angles, so this would be, well, we don't know. We can do 70 here, vertical, and then we can do 111 here. Or you know what we could do? We could do linear pair. So this is going to be 110. All right, we do 180 minus 70 is going to give us 110. So then now we have alternate exterior angles. Those alternate exterior angles are not congruent, so we're going to say no, not parallel. Okay, they're not parallel lines because the alternate exterior angles are not congruent. Here we have 58 and 122, so those are same side interior angles. In order for those lines to be parallel, the same side interior angles need to be supplementary. So if we do 122 plus 58, we get 180. So they are supplementary. Therefore, yes, P is parallel to Q. Okay. Then here we have corresponding angles. Those corresponding angles both have an angle measure of x, which means they're congruent. And since corresponding angles are congruent, then yes, P is going to be parallel to Q. So we're just working backwards. Instead of saying they're parallel, therefore these are congruent, we're saying since these are congruent or since their measures are equal, then the lines are parallel. Here they're not equal, so the lines are not parallel. Here they're supplementary, same side interior are supplementary, therefore they're parallel. Here we have corresponding, they're the same, they're congruent, therefore the lines are parallel. The angle measures are equal, therefore the angles are congruent, therefore the lines are parallel. Okay, now we go to the proofs. So they kind of use 1 and 2 as an example to get to 3. So let's do 1 and 2 first here. So we start statements, reasons. Reasons. Okay. So we start with our given. We're given that angle 1 is congruent to angle 2. We want to prove that A is parallel to B. So right now we have alternate interior angles and we know they're congruent. So if we use the converse to the alternate interior angle theorem, again, we're abbreviating as we've done in class. This is converse to the alternate interior angle theorem. which tells us if the alternate interior angles are congruent, which they are, then the lines are parallel. So now we know that A is going to be parallel to B. And that's it. That's all we needed to use. Okay, number 2, we have statements, reasons. Okay. First step is always your given. So we're given 2 pieces of information here. We're given that M is parallel to N, and the measure of angle 3 equals 80. And we want to prove the measure of angle 4 equals 100. Well, we know the lines are parallel, so we can use the same side interior angle theorem. Same side interior angle theorem or consecutive interior angle theorem to tell us that angle 3 and angle 4 are supplementary. And we know the definition of supplementary. This is kind of a review problem. Definition supplementary is going to tell us that the measure of angle 3 plus the measure of angle 4 equals 180. We can then substitute in the measure of angle 3 here. So it's going to be 80 plus the measure of angle 4 equals 180. And that is substitution. And then we can do the subtraction property of equality. When we subtract 80 from both sides, we get the measure of angle 4 equals 100. This was the subtraction property of equality. Right? We're subtracting 80 from both sides, and we get the measure of angle 4. Right? Minus 80, minus 80. So here we have the 2 different sides, right? So this one's telling us the angles are congruent, the alternate interior angles are congruent. So we use the converse to the alternate interior angle theorem, which says if the alternate interior angles are congruent, then the lines are parallel. Here we have it the other way. They're giving us the lines are parallel, so we're going to use the straightforward one, the not converse one, and that's same side interior angle. So we're going to use the same side interior angle theorem to tell us that angle 3 and angle 4 are supplementary. Then we can use the definition of supplementary to say that the measure of angle 3 plus the measure of angle 4 equals 180. And we can then substitute in the measure of angle 3, which is 80. Okay, we can replace this. And then we subtract 80 from both sides, and that's our subtraction property of equality. Go to the next one. So they're giving us the statement, the given first here. So what we have is angle 1 is congruent to angle 2. And the measure of angle 3 equals 88. So we want to prove the measure of angle 4 is 92. So what we're going to want to do is use the fact that these are same side interior angles. But we need to know that those angles are supplementary. And right now, if we look at the diagram and what's given to us, we don't know. Okay, we need to show that C and D are parallel. But luckily, we have this piece of information here. 1 and 2 are corresponding angles. So we can use the converse to the corresponding angle theorem. The converse to the corresponding angle theorem tells us that if the corresponding angles are congruent, then the lines are parallel. So we can conclude that C is parallel to D using the converse to the corresponding angle theorem. Since the angles are congruent, the corresponding angles are congruent, lines C and D are parallel. Well, if lines C and D are parallel, then we know the same side interior angles here are supplementary. So by the same side interior angle theorem, we know that angle 3 and angle 4 are supplementary. We know the definition of supplementary means the measure of angle 3 plus the measure of angle 4 is going to be equal to 180. We can substitute in what we know. We know the measure of angle 3 is 88. So that's going to be 88 plus the measure of angle 4 equals 180. That's substitution. Okay, subtract 88 from both sides. We get the measure of angle 4 equals 92 by the subtraction property of equality. And that's what we're trying to prove. So we need to use the fact that angle 1 was congruent to angle 2, and those are corresponding angles to show that C and D were parallel. Once we have parallel lines, we know that 3 and 4 are going to be supplementary because they're same side interior angles. So the same side interior angle theorem tells us they're supplementary. Then the definition of supplementary tells us the measure of angle 3 plus the measure of angle 4 is 180. We can substitute in what we know, the 88 degrees. Subtract it from both sides, and you get the measure of angle 4. Let's look at number 3. Okay. So they're giving us some information here. And they're telling us angle 10 is congruent to angle 9. Those are alternate exterior angles. We also know the measure of angle 5 is 5x plus 4. And we know the measure of angle 3 is 6x minus 16. Well, let's use the fact that we have angle 10 and angle 9 that are congruent. Those are alternate exterior angles. So by the converse to the alternate exterior angle theorem, okay, the converse to the alternate exterior angle theorem, that's going to tell us that lines A and B are parallel. Converse to the alternate exterior angle theorem. Since the angles are congruent, the alternate exterior angles are congruent, lines A and B are parallel. Okay, once we know lines A and B are parallel, we know that our alternate interior angles are congruent. So we can use the alternate interior angle theorem here. Okay, to tell us that angle 3 is congruent to angle 5, right? Also, if the lines are parallel, we just showed they are parallel, then the alternate interior angles are congruent. Therefore, by the definition of congruent, we know that the measure of angle 3 equals the measure of angle 5. Congruent means their measures are equal. And then we can substitute in. So we have the measure of angle 5, and we have the measure of angle 3. So substitute those in, and we're going to get 6x minus 16 equals 5x plus 4 by substitution. We can subtract 5x from both sides. So we get x minus 16 equals 4. So that's going to be subtraction property of equality. Then we can add 16 to both sides. And we get x equals 20. And that's the addition property of equality. And there's our proof. So they gave us angle 10 and angle 9 are congruent. Those are alternate exterior angles. So we use the converse to the alternate exterior angle theorem to tell us that the lines A and B are parallel, because if the alternate exterior angles are congruent, which they are, then the lines are parallel. Then we can, since the lines are parallel, we can now use the alternate interior angle theorem to say angle 3 is congruent to angle 5. Since the angles are congruent, their angle measures are equal. We can substitute in. So we substitute it, we subtract 5x from both sides, we add 16 to both sides, and we're good. Okay. I don't know if you guys can hear my stomach or not, but I haven't eaten today yet. So let's go on to the next one. Okay. It's telling us that angle 2 and angle 4 are supplementary. And the measure of angle 1 is 40, so this is our given. Okay, so 2 and 4 are supplementary. So we're going to use our converse to the same side interior angle theorem, or consecutive interior angle theorem, to say that lines A and B are parallel. Since the same side interior angles are supplementary, we can conclude that the two lines are parallel. These same side interior angles are supplementary, therefore the lines A and B are parallel. Once we know the lines A and B are parallel, we can use our angle theorems. So we're at 1. Okay, we're trying to get to 8. Okay, we can't go directly from 1 to 8, so how about we go from 1 to 5? Okay, we'll go from 1 to 5 and then 5 to 8. So these are corresponding angles, so let's use the corresponding angle theorem. CAT, corresponding angle theorem. We know if the lines are parallel, and look, we've just shown that they are parallel. The corresponding angles are congruent. So we're going to say angle 1 is congruent to angle 5. Well, we know if angles are congruent, their measures are equal. So we know the measure of angle 1 equals the measure of angle 5 by the definition of congruent. Right? It's the same process we used before. And we also can substitute in the measure of angle 1. So we now know that 40 degrees equals the measure of angle 5. So we can substitute that in. I'm sorry, 5. So now we're at 5, we're trying to get to 8. So we know that 5 and 8 are a linear pair, so we're going to use the linear pair theorem. The linear pair theorem says that linear pairs are supplementary, so we're going to say angle 5 and angle 8 are supplementary. Okay, and then again, we can use the definition of supplementary. Say that those angle measures add up to 180. So the measure of angle 5 plus the measure of angle 8 equals 180. Luckily, we know the measure of angle 5 here is 40, so we can substitute that in. So we're going to get 40 plus the measure of angle 8 equals 180. That's substitution. Substitution. Okay. We can subtract 40 from both sides. So we're going to get the measure of angle 8 equals 140. And that is subtraction property of equality. Okay? And that's what we're trying to prove. So again, we're trying to get to 8, and we have 1. So we're trying to go from 1 to 8. We can't do anything yet, though, because we don't know if the lines are parallel. So we need to first show the lines are parallel. We do that by using this information. Angle 2 and angle 4 are supplementary. Since they're supplementary, by the converse to the same side interior angle theorem that says if the same side interior angles are supplementary, which they are, then our lines are parallel. So then we say lines A and B are parallel. Once the A and B are parallel, we can do, again, whatever we wanted here. We could have done linear pair and then alternate exterior. We could have done linear pair and then corresponding. We could have done vertical and then alternate interior and then linear pair. However you want to get there, we can do that now because we now know A and B are parallel. So what really changes in this one in terms of new information is this right here. Okay. After that, it's the same thing we've always been doing. We just needed to first show that the lines were parallel, and we did that with the converse to the same side interior angle. Let's go to the next page then. and look at what's next. So we've already used the transitive property, so let's go ahead and do this proof. We know the transitive property says if A equals B and B equals C, then A equals C. And we did that for angles or congruent statements as well. If A is congruent to B and B is congruent to C, then A is congruent to C as well. Or if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. Okay, if two things equal the same thing, they equal each other. Right, so here's our given. They're giving us this information. Angle 2 is congruent to angle 1, and angle 1 is congruent to angle 3. So right off the bat, we can use our transitive property. Here we have angle 2 is congruent to angle 1, angle 1 is congruent to angle 3. So since angle 2 and angle 3 are both congruent to the same thing, they're going to be congruent to each other. So for step 2 here, we're going to say angle 2 is congruent to angle 3. That's our transitive property. Okay. And what do we notice about 2 and 3? Those are alternate exterior angles. And so we can use the converse to the alternate exterior angle theorem. Right? If our alternate exterior angles are congruent, then our lines are parallel. So we can then conclude that these two lines here, which don't have names, let's give them names, A and B. We can conclude that line A and B are parallel. And if our lines are parallel, our theorems are all going to work. So we have 5, again, we have 5 and we're trying to get to 6. And we now know the lines are parallel, so we can look at these, and these are corresponding angles. So we can use the corresponding angle theorem, CAT. Corresponding angle theorem tells us if the lines are parallel, which we've just determined they are parallel, by the converse to the alternate exterior angle theorem. If they're are parallel, then the corresponding angles are congruent. So we can say angle 5 is congruent to angle 6. If the angles are congruent, we know their measures are equal by the definition of, I'm sorry, it's 5, yeah, it is 5 and 6. The definition of congruent. And then we can substitute in what we know. So we have the measure of angle 5 equals 64. So we can say 64 equals the measure of angle 6. That is substitution. And if we wanted to be perfect, again, this is perfectly fine. It's not perfectly fine, it's fine. If we wanted to be perfectly fine, we would then use the symmetric property. Okay, to say that the measure of angle 6 equals 64. And then we come down to our last theorem on here. That says if M is perpendicular to T and N is perpendicular to T, then lines M and N will be parallel. So basically we're saying here, we have two sets of perpendicular lines. That two lines are perpendicular with T. That means they're all going to be right angles. So again, you could really use any theorem here. You know, it's just we'd have to say they're both right angles, and then we'd have to say those right angles are congruent, and then we'd have to use the converse to whatever angle pair we want to use. So it's easier just to do it all in one step here with the perpendicular transversal theorem, which says that if you have two lines that are perpendicular with the transversal, then those lines are parallel. Okay, so perpendicular transversal theorem, perpendicular transversal theorem here would tell us M is parallel. Okay, if we wanted to go through and prove it, again, the idea here is you have right angles. So if you wanted to use these pair of angles, those are corresponding angles. So you would say that this angle is a right angle, and this angle is a right angle. Therefore, by the right angle theorem, those angles are congruent. And since those angles are congruent, and they're corresponding angles, we can then conclude that M and N are parallel. But instead of doing all that, we can simply skip ahead and just say M is parallel to N. And then we have a few proofs using this theorem below. Let's go ahead and use them. Okay, so they give us that S is perpendicular to G, and G is perpendicular to H. So here we have two sets of perpendicular angles or lines. So these two lines, S and H, are both perpendicular with G. Therefore, we know S and H are parallel by the perpendicular transversal theorem. Otherwise known as PTT, perpendicular transversal theorem. Since we're trying to prove that the measure of angle 72 is, measure of angle 5 is 72, and we're starting at 1, so we're going from 1 to 5. These are corresponding angles. Okay. There's shorter step on us. Okay, so the corresponding angle theorem is going to tell us if the lines are parallel, and since they're parallel, we know that angle 1 is congruent to angle 5. Okay, then there should be another step in here, okay, that says the measure of angle 1 equals the measure of angle 5. Okay, that's your definition of congruent. Okay, and since your angles are congruent, your measures are equal. That was step 4. And then we can substitute in. So we can substitute in 72 for the measure of angle 1, and we get the measure of angle 5 equals 72. So that's substitution. Then we have, I believe, just 2 more. Okay. Right here, F is, so this was our given. So if we're going to use the perpendicular transversal theorem, F is perpendicular to M, and F is perpendicular to N. Therefore, we conclude that M and N are parallel. Okay, and that's our perpendicular transversal theorem, PTT. Okay, we want to prove that the measure of angle 3 is 150, and they're giving us the measure of angle 6. So we have to go from 6 to 3. Okay, I'm going to do corresponding with 2 and then linear pair. So I'm going to use the corresponding angle theorem. Okay, to tell me that angle 6 is congruent with angle 2. Therefore, we know the measure of those angles are equal to each other. The measure of angle 6 equals the measure of angle 2 by the definition of congruent. We can then substitute in 30 for 6. So we can say 30 equals the measure of angle 2. We're substituting this in for 6. So we're replacing the measure of angle 6 with 30. That's substitution. And then we know angle 2 and 3 are a linear pair, so we can use the linear pair theorem. Linear pair theorem. Okay, that tells us angle 2 and angle 3 are supplementary. We know by the definition of supplementary the measure of angle 2 plus the measure of angle 3 equals 180. We know the measure of angle 2 is 30, so we can substitute that in. So it's going to be 30 plus the measure of angle 3 equals 180. That's substitution. Okay. And then our last step here, then, we subtract from both sides. Right, we subtract 30 from both sides. We get the measure of angle 3 equals 150. And that's subtraction property of equality. Subtraction property of equality. So we use the fact that we have two sets of perpendicular lines. F is perpendicular with both M and N. Therefore, by the perpendicular transversal theorem, we know that M is parallel to N. Since M is parallel to N, we know our corresponding angles are congruent. So we know that by definition congruent, the measures are equal. We can then substitute in the 30. So we know the measure of angle 2 is 30. Then we have to go from 2 to 3. So those are supplementary. By the linear pair theorem, linear pairs are supplementary. Definition supplementary tells us those angle measures add up to 180. We can substitute in them at 30. We can substitute that in here. And then we subtract 30 from both sides, and we get the measure of angle 3 equals 150. Now the last one here. Oops. So we're giving us a given. So M is parallel to N. We know the measure of angle 3 is 128. So we need to get from 3 to 5. So they want us to go from 3 to 4 here. So we know by the vertical angle theorem tells us vertical angles are congruent. Angle 3 is congruent to angle 4. Okay, therefore we know the measure of angle 3 equals the measure of angle 4. And then we can substitute in 128. So we get 128 equals the measure of angle 4. So again, this was definition congruent, and this was substitution. So this should all look very, very familiar. Okay, then we want to go from 4 to 5. So we know 4 and 5 are supplementary. Okay, we know they're supplementary because of the same side interior angle theorem. Right, which tells us if the same side interior angles are supplementary. If the lines are parallel, then the same side interior angles are supplementary. Okay, and then the definition of supplementary tells us that those angle measures add up to 180. We can then substitute in 128. So we get 128 plus the measure of angle 5 equals 180. That was substitution. And we can subtract 128 from both sides. And we get our eighth step here, then the measure of angle 5 equals 52. And that was subtraction property of equality. Okay, so that's kind of like a review problem to finish it off. Lines are parallel, therefore vertical angles are always congruent. Since they're congruent, their measures are equal. We can substitute in the 128. Okay, now we're at 4. We want to get to 5, so 4 and 5 are supplementary by the same side interior angle theorem. Therefore, since they're supplementary, they add up to 180. Substitute in the 128, subtract it from both sides, and you get the measure of angle 5 equals 52. Okay, so that's it for the converse theorem proofs.